Why does a moving charge produce a magnetic field? Welcome back to the channel, and today we will discuss just this. If you were in class +2 and you have always wondered maybe the explanation is very complex or maybe I don't know the basics well enough to understand it, let me assure you it's not. You just need to know one thing, that is length contraction. It comes from Einstein's general theory of relativity. Einstein isn't that heavy of a word as you might think in the beginning. So it states this. Where is it? Yeah, length contraction. You can pause the video to see for yourself. Here's a bit of the mathematics that's there. But in simple words, measurement of lengths as well as of time intervals are affected by relative motion. The length L of an object in motion with respect to an observer always appears to the observer to be shorter than its length L naught when it is at rest with respect to him. So, if I am an observer and this is an object and it's at rest, its length will appear different than if this object is moving. It will appear shorter. And when this object will come to a rest again, its length will appear larger. That's length contraction in layman's term. So we will think of this scale as a conductor which has positive and negative charges. Overall, this conductor is neutral. Now suppose a current is flowing upwards. That would mean that electrons are flowing downwards, because the motion of the electrons is opposite to the motion of the current. That's the convention that we use. So if we take a negative charge and if it's going downwards, so with respect to the electrons of the conductor, both of them are at rest. This negative charge and the electrons of the conductor are at rest. What about the positive charge? The positive charge with respect to this negative charge will appear to be moving upwards. So when an object is at rest and something is moving with respect to it, its length will appear shorter. At the same time, we have come to a conclusion that when something stops, its length is enlarged. So the electrons of the conductor are evenly spaced but at larger distance as compared to the positive charge. So the positive charge in a small section is larger as compared to a negative charge. So the positive charge will attract this negative charge. That is the force that this charge is experiencing, that we call the magnetic force. So that's it. Hope you like this video. Do leave a like,